Okay, so SBAC review, okay? We're going to do a couple things that I know you guys have seen before. I know that you guys have seen these before. I just want to make sure that we're pretty clear on, okay? So, first thing we're going to go over are square roots and squares, okay? So, square numbers and square roots. First thing you need to remember is that a square number, yeah. A square number is a number with an exponent of what?
I don't know.
Something squared has an exponent of 2. Okay, not a trick question. And a square root.
Oh wait, that's square number.
A square root is a number with an index of 2. Okay? An index means the number inside this little bar. Okay, that's called an index. Sorry. So a square number is a number with an exponent of 2. Okay, a square root is a number with an index of 2. Okay, so square number, has an exponent of 2. Square root has what's called an index of 2. This is the index number right there. Okay, so perfect square roots. Okay, perfect square roots, you probably already know them. Okay, but perfect squares are the squares of whole numbers. Okay, are the squares of whole numbers. Okay, I guarantee that you guys probably already know this. Okay, so if you're squaring a number, okay, let's say for instance we are going to square 4. Okay, that's really not 4 times 2, but it's really 4 times 4. So what is 4 squared? 16. Okay. You can also go backwards, okay? The square root of a number, square root of 16 is basically the same thing as writing square root of 4 squared. Since there's 2 exact things, it will come out to be just 4. Okay, so like I said, totally basic. You guys have done this a lot before. Okay, so if you square 4, you get what? If you square 4, you get what? 16. And if you take the square root of 16, you get 4. Okay? So they go hand in hand. Okay? If you know your squares, you probably already know your square roots by default. Okay? So, I want you guys to fill in this chart of perfect squares and perfect square roots. Okay? Fill in that chart. You guys already know this, I think. Fill in the chart of perfect squares and perfect square roots, please.
My hair is flaky.
You got a whole bunch of flakes in your hair.
Yeah, dude. Should stop using that gel. It's the LA look.
He's Dumbo.
Stop, guys.
120.
Okay, so you should know all of these, okay? You should know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared, 36.
49.
Thank you.
64.
Okay.
Hey, you're taking my thunder.
100.
121.
Oh my God, if you're right.
Wait, it says right under it.
144. I know, but no one knows. And 169, okay? Also, what is 14 squared and 15 squared?
I do not know.
141.
1, 2, 3, 4, 5.
Listen. If you know 13 squared, you also know 14 squared, because all you have to do is change the last 2 numbers. So 196, and then 15 squared is 225.
Oh, do we have to do that? 14, 15.
Hello.
Wait, what'd you say?
I said, hello.
Hello.
Okay, then here. These are going exactly backwards.
Wait, what is the little line thing for?
Shut up, Sean.
The square root? This thing?
Yeah, that little.
That's called the square root. So what multiplied by itself gives you those numbers? So what multiplied by itself gives you 1? 1. What multiplied by itself gives you 4?
2.
Yeah.
2. So we're just going backwards, okay? So your square roots. What multiplied by itself gives you 9? 3. Okay, yeah, obviously this is, yes, thank you.
9, 10.
Wait, you're
11,
messing me up.
12, 13.
Oh, wait,
Get out
I'm
of
going
here.
in order?
Yes, they go in order.
5, 6, 7, 8.
For right now, it doesn't matter.
Hi, Miss Kim's recording.
Thank you. Okay, also, you need to know that the inverse operation, okay, the inverse operation of squaring a number is finding the square root. So basically, to undo an exponent, you use a radical. Okay, and a radical, this is called a radical. You can also call it a root. Okay, a radical or a root, that's the same thing.
Is this going on the internet?
Probably.
Wait, what?
Wait to
Why?
hear myself. Definitely looking up these.
These are notes.
Do they go on the internet?
Yes.
Yes.
You know, keep
Obviously, she has never used the website.
Okay, guys. Hey,
Stop talking.
this might be a really good example day to point your parents to say, why don't you watch the video today and see how lovely
please
your
don't.
children were. Then please stop talking.
That's why your video.
My
Please
mom
stop
also
talking.
Well, my mom doesn't
Yeah.
talk much, so she won't blame me as long as I'm paying attention. I'm paying attention.
My
I
mom.
got the notes
Thanks.
also
My
talking.
mom won't care as long as she sees my
Okay,
notes are
okay.
gone.
Can we please just stop talking?
That would just laugh.
Okay, so applications here. Okay, applications mean how do we actually use this? So you can, listen please. Okay, you can take the square of a number and you can take the square of a variable. Okay, so first thing you're going to do is we're going to ask you to take the square root of the perfect square out. So what is the square root of 9?
3.
3. Okay, then a variable squared, variable means one letter, or means letters, excuse me. A variable squared comes out just by itself. So the square root of x squared is just x. Okay, if you needed to see that broken down, this is the same thing as 9 would break down to 3 and 3, x would break down to x and x, and then you take out a pair, or a representative from each.
David?
Thanks. So weird.
Especially that guy, huh?
Angel and Cece.
Lunch. Detention.
After school.
After school.
Okay, then, listen. If you have a fraction that needs to take a square root, okay, the first thing you want to do is break this into two baby roots. So, root 25 over root 4. Then, what's the square root of 25? 5. And what's the square root of 4? 2. Okay, so you take square roots of fractions just like you do whole numbers. Does not change anything. Does not change anything.
This is why me and Tanya used to fight each other.
That's your answer, yeah. 5 over 2.
Whoa, what happened to your voice?
I'm sorry.
Where do you get 25 and 4?
It's the problem. The problem gave it to you.
What's wrong with your voice?
I can hear her.
Okay, then,
Me when I voice
technically, listen. Okay, you need to know this because you guys might not know this already, okay? How do you undo a square?
with the B in math.
How do you undo a square? You put in a square root, okay? There's a rule though. Listen, okay? So to undo the exponent, solve by taking the square root of both sides. What you might not know though is if your problem did not come with it, if you introduce the square root, okay? If your problem did not come with it. So like this problem came with a square root in it. This problem did not. If you introduce a square root, you have to put plus or minus in the next step.
I needed that too.
Okay? So if you introduce the square root, automatically your answer is going to have a plus or minus in it. So what's the actual answer here? X equals plus or minus, what's the square root of 25?
Plus.
5. So you actually have two answers here. The actual answer here is plus or minus 5. So there's two different answers there, positive 5 and negative 5. Yes.
Check. You know you can get off a shot. Oh wait, can
Say
you
what?
scoot it more to the right? Oh wait.
Oh, sorry.
Ski walk?
Put plus, minus in the next.
You did?
Stop that.
Okay, next one. How about if I wanted to solve here? X squared equals 4 over 9. How do I undo the exponent? What do you do? Take the square root of both sides. So if you're going to take the square root of both sides, since my problem did not come with the square root in it, what do I have to put in the next step? Plus or minus. So x equals plus or minus, what's the square root of the numerator, the top? 2 over, what's the square root of the denominator? 3. So your actual answer here, you have 2 answers. X equals plus or minus 2/3.
That's weird.
Yes, that is my phone.
Undo and radical.
Do not put me in advanced. Like, I'm not going to.
Burning my skin.
This is so hard.
Okay, last one on this page. Okay, how would you, Anna, could you please talk? How do I start undoing the 2 here? How's the 2 attached to the x squared?
I have to divide.
By multiplying.
By multiplication.
Oh
So to undo multiplication, you divide both sides. You divide both sides, we're going to get x squared equals 18 divided by 2 is 9. Is 10. Okay, so to undo the coefficient, we divide it on both sides. Then solve by taking what? How do you undo a square?
You do
The square root of both sides. Okay, what's the square root here?
3.
3.
Close.
Chewy.
If I introduce the square root,
Positive
plus or minus
Plus or minus
3.
Out of brain for it.
Okay, plus or minus 3. You have to write both of them. If you don't write both of them, it will be wrong. If you do not write both of them, it will be wrong.
So if you write both of them, you right.
No.
Yeah, so you have to, if you introduce the square root, you have to put in plus
You
or
have to
minus.
exactly write it
Wait,
like
so
that.
you
Yes.
write both and it's right?
You have to write just like this. That's positive 3 and negative 3.
What if you put it the other way?
Is that all we're doing?
There is no other way.
There's 30 minutes of notes.
That doesn't make any sense.
Really? 30 minutes of notes?
Again.
Okay, next one. Listen.
Why use the stupid breakfast?
Okay, next one. Okay, non-perfect square roots. Okay, so that means not perfect radicals. So here, fill in this chart. We've already done it before. Okay, table of perfect squares. The 1 all the way through 10.
Shh, too loud.
So, first thing you want to do.
Sean, get off your phone. She's looking right at you. Okay, I see.
She's waiting.
Now you're putting it in your nose.
Ow.
Okay, so fill in your table of perfect square roots, okay? Then, if we want to look at number 1, we want to know between which 2 perfect squares, where is root 7 on a number line? Okay, so between which 2 perfect squares does square root of 7 fall between? What are some numbers that you know that are close to being the 7?
6.
Okay, no. Perfect squares, so square roots. So if you look at the square roots, 7 is in between which 2?
64 and 36.
4 and 9.
4 and 9.
What?
Okay, so
What?
root 4
So
I don't see it.
and root 16, or root 9, excuse me. So we're looking at the squares. Okay, look at the radicals.
Yeah, I think.
So here, 4 is actually equal to 2. Not root 9 is actually equal to 3. So if root 7 is in between 2 and 3 on a number line.
So wouldn't be like
about time to
2.5.
It is, but if we're just approximating, this one's asking where would this be on a number line.
But if you would,
We will get there. We will get there. Okay? So, the reason is because the radical 7 is between
My homework is for the Asian
the 2 perfect squares. Root 4 and root 9. So it's in between the 2 perfect squares of radical 4 and radical 9. Okay? Same thing here. Between which 2 perfect squares does root 48 fall?
Oh shoot.
Which 2 is it in between?
I don't know.
Normally. Oh, perfect.
48 is in between which ones?
36 and 49.
36 and 49. So in between root 36 and root 49. So between which 2 whole numbers is this? What's square root of 36?
7.
6 and 7.
So we
Okay, so between 6 and 7. The reasoning is exactly the same.
Wait, why do you have to write?
Well, I could say because the root 48 is in between the two perfect squares, root 36 and root 49. But we already talked about it, so I'm not making you write it right now. Okay, next thing you need to know how to do is approximating perfect squares. Okay, approximating perfect squares. This looks really complicated, but I'm going to show you guys a kind of easier way to do this, okay? So, between which two perfect squares does root 6 fall between? Where's root 6 on a number line? In between which ones? Root 4 and root 9. Okay, so in between 2 and 3. Okay, there is a process that you can use here, but instead of teaching you guys a new process, we're just going to cross this out, and we're going to figure out, how would you figure out what the actual number here is? If I was asking you for rounding to the nearest tenth, find this number to the nearest tenth. No calculator. You know it's in between 2 and 3.
So would you estimate only? So
we're going to estimate. So take a guess. Where do you think it is between 2 and 3? 2.5? Okay, so you'd actually have to do some multiplication. Okay, well, let's check.
2.6.
You have to check things. So you actually have to do some multiplication. Okay? You can do the multiplication here.
It's 3.
You should be able to do the multiplication here. So 6.25. Do you think you could get closer than this?
No.
Okay, would you have to go up or down? Down. So I wouldn't go down very much, but I would check 2.4. Okay, you can do your own multiplication, regardless of if you think you can. So this would be 5.76. Which is it actually closer to? 2.4 or 2.5?
2.5.
2.4.
I mean 2.4.
This is closer to 2.4. Okay, this would be closer to 2.4. It doesn't have to be. It's whichever it's closer to. Whichever it's closer to.
I'm a lip sync.
Okay, I'm going to let you guys skip this one. Okay, I'm going to let you guys skip this one, and we're going to go to cube numbers and cube roots. Cube numbers and cube roots.
Dude, why are you?
Okay, a perfect cube and a perfect cube root. I don't know. Okay, cube roots and perfect cube roots means an exponent of what? A perfect cube means you're multiplying a number by itself how many times? 3 times. Okay, so basically like 1 times 1 times 1. What's 1 cubed? 1. What's 2 cubed? 8. What's 3 cubed? 27. Okay, we're not doing 3 times 3. We're doing 3 times 3 times 3. How about 4 cubed? 64. How about 5 cubed? 125. 6 cubed? 216. 7 cubed?
I got this.
343. 8 cubed? 512. 9 cubed? 729. And 1,000. Okay, now, if you were asked to find this, you could actually multiply it out. Okay, it's not so much that I want you to have these memorized, but you have to be able to go backwards. Okay, so if you look at, and I ask you, what's the cube root of 216? You have to know that that's 6. Okay, you could break things down, but you really do need to kind of memorize these. Okay, or at least be able to recognize them. So here, what's the cube root of 1? What multiplied by itself 3 times equals 1? 1. What's the cube root of 8? 2. Cube root of 27? 3, and obviously keep going. So 4 all the way through 10.
4.
Stop, please. So, think about this. What number multiplied by itself 3 times is equal to that number?
1.
So when you're thinking about cubes, you have to think about what multiplied by itself 3 times gives you that number.
Okay. Gets 10? There's no answer, Jack. Wait, to get what?
So something like cube root of 8. What multiplied by itself equals 8? 2. What multiplied by itself 3 times gives you 216? 6. We're just filling in a chart.
Okay.
I did that.
Sean, next,
Okay,
please.
then you're done.
Oh.
Okay, we will come back for more notes in a little bit. Okay, we will come back for